Hello, this is Mr. Greisman. In this vodcast, we're going to learn about covalent bonds. So, what is a covalent bond? You've already learned about ionic bonds and how ionic bonds are formed by the transfer of an electron from a metal to a non-metal and the resultant electrostatic attraction between the two ions to form the bond. Well, the covalent bond is a different situation. The covalent bond results from a pair of electrons being shared. The key word there is shared between two or more non-metals. So here we're not only talking about not exchanging electrons, we're also talking about non-metals bonded to non-metals. Now, the bonding occurs due to an attractive force between the electrons and the atomic nuclei or the protons. So the protons of each atom are not only attracting their own electrons, but in the covalent bond they're attracted to an adjacent atom's electrons. Now these things occur, that is, the covalent bonds form, because nonmetals tend to have high electronegativities. Electronegativity, don't forget, refers to an atom's ability to attract electrons to itself. And they're not really willing to give up any electrons. And so what we're looking at is a kindergarten situation where everyone shares. So let's look at an example of the formation of hydrogen. Hydrogen is formed when two hydrogen atoms form a hydrogen molecule. So there's our nucleus of our hydrogen atoms. We have one proton, no neutrons. And we also have our electrons. Now you've noticed that one electron is red and one is blue. And that means that one of those electrons is coming from one of the atoms, and the other electron is coming from the other atom. And together they make a covalent bond. Molecules are really the smallest unit of a covalent bond. So a molecule is an electrically neutral group of two or more atoms held together by covalent bonds. So the first type of molecule is what's called a diatomic molecule, which is a molecule made up of two atoms. Oxygen gas is an example. Other examples would include nitrogen gas, hydrogen gas, fluorine gas, and chlorine gas. The diagram that you see below the oxygen with the lines and the dots will become more clear to you as this vodcast progresses. In contrast to diatomic molecules are polyatomic molecules, like carbon dioxide, in which you have more than two atoms forming covalent bonds to make up the molecule. And the structural formula for that looks like what you see below the chemical formula, and that will become apparent momentarily. In order to determine how many bonds an atom will form, we have to refer to something called bonding capacity. And bonding capacity refers to the number of covalent bonds an atom is capable of forming. And if you look at the table, you can see that hydrogen, for example, is in group 1, has one valence electron and one bonding electron. Look carefully there at nitrogen and oxygen because the number of valence electrons does not correspond with the bonding capacity. You'll notice that carbon has the largest bonding capacity. I've included all of the halogens in the bottom left-hand corner because they all behave in the same way. In order to draw these molecular Lewis structures, you must follow certain rules. The first rule is that you need to draw the Lewis symbol for all the elements involved. Remember, the Lewis symbol just shows the valence electrons around the elemental symbol, and you place the one with the highest bonding capacity in the center. So if we look at carbon dioxide again for an example, carbon having a bonding capacity of 4 is in the center surrounded by oxygen atoms. Now none of these are bonded at this point. Rule number 2 then says to count the total number of valence electrons available from all atoms involved. you'll add 1 electron if you have a negative ion, and you'll subtract 1 electron if you have a positive ion. So if we count all of the electrons around the carbon and the oxygens, we get a total of 16 valence electrons amongst all 3 of those atoms. Some of these electrons are what are called bonding electrons, and some of them are called lone pairs of electrons. Now, I haven't indicated all of those. You'll notice that the bonding electrons will be involved in the bonding. The lone pairs do not participate in bonding. If we continue, the third rule says to place 1 pair of electrons between the central and each of the outer atoms. And make sure to include all of the lone electrons. So if we do that, you can see we've got carbon surrounded by oxygen. And if we look here, here's going to be 1 pair of electrons. Here's going to be another pair of electrons that are going to form a covalent bond. Here's another pair over here. And then the last pair is over there. You'll notice I've also got the lone pairs of electrons around the oxygens. The next thing to do is to determine if each element has fulfilled the octet rule by counting bonded pairs as 2 electrons and lone electrons as 2 electrons. So if we count oxygen, 2 electrons here, 2 electrons there. So it's got 4. Carbon is starting with 4, but now that it's bonded, we count each of the bonds as a pair of electrons. So carbon has a total of 8 electrons around it. And now that oxygen is bonded with carbon, there are 2 there, and there are 2 there. So we have a total of 8 on that oxygen, and we have the same here, a total of 8 on that oxygen as well. It's very important that we pay attention to obeying what's called the octet rule. Each element surrounded by 8 valence electrons. It may be necessary to create multiple bonds until the octet rule is obeyed, which is exactly what I've done between the carbon and the oxygen. Continuing, if the ion formed is polyatomic, we place brackets around the structure and write the charge outside the bracket. There are 2 ways to convey 2-dimensional diagrams of molecules. One is the Lewis structure, and one is what's called the structural formula. When we're using the structural formula, which is probably what you're mostly familiar with, we replace the bonding pairs of electrons with a line. So I've got my Lewis structure of carbon dioxide. And you can see there I've got 2 pairs of electrons involved in the bonds. Below that is the structural formula. So you can see that we have replaced the 2 pairs of X's and O's with 2 lines, indicating double bond. So a single bond is a single line, a double bond is a double line, and a triple bond is 3 lines. Thanks very much for watching.